Today, I'm going to run through a tutorial about how to use LTspice. This is a really good tool. I used LTspice to do all the simulation, all the pre-lab plots for 346. It'll get you really accurate results that you can compare with the data you get in lab, and it just makes the whole process a lot cleaner, nicer, simpler. All right, so let's get to it. First up, all right, so once we have LTspice open, click on the new schematic button so that way you can start building your circuit. In order to do so, first thing you need are some components. And luckily enough, up here at the top, we got resistor, capacitor, inductor, diode. And if you need anything else, go to the component bin. And in this case, I need a voltage source. So I'm going to head over to the voltage. Click OK and drop that down. I also need a resistor because I'm building a VRD circuit. If you want to rotate a component, hold Control, press R. If you want to mirror flip a component, hold Control, press E. In this case, the resistor, it doesn't matter. But for the diode, it does. In this case, I'm going to forward bias it, so lay it down there. And now I need to place a ground. And don't forget ground, because if you do, the analysis techniques that Spice comes with won't work, and you'll be left wondering why it's not working. Ground is just another sort of component, and you find it up here at the top. And right next to it is the wire button. So go ahead and click that and match the nodes on your components together. If you want to connect a component with a diagonal wire, hold Control and drag your wire, and I'll show you. So I just held Control to do that. It's not really necessary, but it can sometimes be handy. In this case, I don't want that, so I'm going to click on the Cut button and just cut it out. All right. So once we have all our components connected, we want to go ahead and change the values and select certain types of these components that we want. In this case, the resistance is not defined. So if you mouse over it and right click it, this dialog box comes up. You can select a resistor and you can add in a resistor value, which is what I want to do. So I'm going to say 100 ohms for this case. I don't care about the tolerance or the power rating, so I'm just going to click OK. For the diode, same deal, mouse over and right click, and you can pick a certain kind of diode. And here a list comes up of all the diodes that are in your diode part library, and I'll show you more about that hopefully at the end of the video. Right now I just want the 1N914 component, so I'm going to click OK and head over to the source. Right click that. If you just want a DC source, this dialog box comes up and you enter your DC value. But if you want, say, an AC source, you have to click Advanced, and this new dialog box comes up. Here you can select Pulse to have a square wave, Sine for sinusoidal input, and of course you can set all the parameters for the sine and for any of these different waveforms. But I just want a DC source, so I'm going to click OK, head back to that first window, and say 10 volts. No series resistance. Thing is, when we go to analyze our circuit, it's going to be really useful if we use labels for all the nodes. It doesn't really matter in this case, but for the pre-lab, it can definitely help you out. So click on this net label button and type whatever you want to type. So in this case, we can do, this is a resistor node, so we can do resistor 1. Click OK. And notice that when I connect it to a wire, the wire turns yellow. So that wire, that node, will now be labeled as resistor 1. It's not necessary, but it can kind of help you identify what's going on when you actually run the analysis. All right, so now we're about ready to simulate our circuit. Head to the Simulate option and go to Edit Simulation Command. because we need to specify exactly what kind of simulation we want to perform. Transient simulation is good for AC analysis. So when you want some sort of analysis, when you want an AC analysis over a set period of time. AC analysis is for small signal AC behavior of your circuit. Noise is looking at the frequency response of your circuit due to a noise input. If you have a circuit with a static DC source, DC operating point will give you the value of the current and voltage drops over any resistor you have in your circuit, any currents through those resistors. But most importantly for 346, and I think almost exclusively what you're going to use, is DC sweep. Because we're going to look at how the circuit changes according to a change in the voltage across the input. So you can sweep several sources, but in this case we only have one. Name of first source to sweep. In this case our name was V1, although you can change that. So I'll do V1. I want a linear type of sweep. Start value 0 volts, stop value 10 volts, increment of 0.1 volts, let's say. It'll give you a text box, and this is really the command that LTspice looks at. You can write this in directly using the spice directive dialog box. You can type it in, but it's easier to let LTspice type it for you by going to the edit simulation command prompt and just entering these values. So once we have that laid down, you can go to simulate and run. Once you hit run, a empty graph plot comes up. So if we want to check the voltage across a component, you hover over the wire that is right next to your component, and as you can see, the cursor turns into a multimeter probe, and you just click there and the graph comes up. So obviously the voltage across the resistor goes up and up as the DC voltage also increases. If you want to see the current, hover your cursor right next to the resistor and it turns into this current meter. And now we get a graph of the current. If you want to see two graphs on the same pane, you click once and you can see both. You click twice and you only see one. So let's check out our diode. As expected, when the diode reaches about 0.7 volts, it starts conducting current through it. And so all is well. If you want to mess with your graph, at specific points, if you mouse over a certain point and then look in the bottom left, it'll show you exactly what's going on in terms of the voltage and the current. So that's easy to find specific values. If you want to copy this to a bitmap image to print, say, go to Tools, copy bitmap to clipboard, and you're all done. Then paste it into Paint. If you want to change the color preferences for the graph, go to Color Preferences in Tools, and here you have all the options to color it however you want. If you want to zoom, just drag and hold the left mouse button and you zoom on a certain portion of the graph. If you want to zoom back out, right click and go zoom to fit, and you get the whole graph back. So if we want to edit a component or add our own, you need to head to the LTspice libraries. So go ahead and go to Computer, My Computer, Program Files, navigate to LTspice, LTC, go to Lib, and then CMP. And here is a couple of standard files. Which file you're going to edit depends on what kind of component you are going to edit. So in this case, I want to edit, say, a JFET. I would go to the standard.jfet file and open it up with TextPad. And this brings me to a bunch of models that you can find in Spice. And if I want to make a new one, what I do is I just copy the dot model paste it in a new line, call it something else. My JFET, for example. And here you can specify, is it an NJFET, PJFET, specify all the parameters. And when you're done, just save and close. In this case, I'm not going to save it, but normally you'd click yes. And when you head into LTspice and you pick a diode, my JFET or whatever you named it should be included in the list of diodes. And it's as simple as that. All right, hope this helped you guys out. Peace.